So now that I've learned how to use matrices to find the area of a triangle, I can adapt that to find the area of polygons. All polygons can be broken up into multiple triangles just by drawing in some of the diagonals. So we should be able to go ahead and draw in a diagonal here, and I'm going to go ahead and connect the vertices -1, 3, and 6, -6 to split this four-sided polygon, this quadrilateral, into two triangles. And then I just need to find the area of each of those triangles using the formula that I had been using to find the area of a triangle before. Now that I've drawn in the diagonal connecting the vertices -1, 3, and 6, -6 to separate this polygon into triangles, I just need to go ahead and find the area of each triangle. In the case of this particular polygon, it only needed to be separated into two triangles. If it had more sides, then it would need to be separated into more triangles, and you would just have an extra step of finding the area of each of those triangles. So now let's go ahead and find the area of each of these triangles, like we had done in previous examples. Now let's go ahead and set up the matrix to find the area of our first triangle. The first triangle there that we had separated the figure into had vertices -1 and 3, 4, and 7, and 6, -6. Go ahead and throw in the column of 1s to have that matrix A that formula was referencing, and now we need to go ahead and find the determinant of this matrix. Again, I don't have any zeros in here, so I'm just going to go ahead and use row 1 to set up that determinant. Remember your sign matrix, plus, minus, plus, minus, plus, minus, plus, minus, plus, for determining the signs when you set these pieces up. So to find this determinant, this is matrix A. The determinant of A would be equal to -1 times the smaller determinant, where I cross off that row and that column, and that leaves me with 7, 1, -6, and 1. And my next number is 3. Again, that's in the position in the sign matrix where there's a minus, so I need to have the opposite of that sign, so it would be -3 times the smaller determinant. Again, cover up the row and the column containing that 3, and I'll have 4, 1, 6, and 1 remaining. And then finally, drop my piece of paper. The last number in there, that row, is +1. Again, I don't need to change the sign of that one, times this smaller determinant. And again, cover up the row and the column to figure out what numbers go in this determinant. So I have 4, 7, 6, and -6. So now I just need to go ahead and evaluate that to get that determinant. So this would be equal to -1 times this determinant. When I evaluate this determinant, it is 7 times 1, which is 7, and then minus the product of the other diagonal, which is -6. So I have 7 minus -6, which becomes 13. Then here I have -3 times this determinant. 4 times 1 is 4, minus 6 times 1 is 6. 4 minus 6 is -2. And then plus 1 times this determinant. I do this one over here. 4 times -6 is -24, minus 6 times 7 is 42. -24 minus 42 is -66. So now continuing to evaluate this determinant, I have -13 plus 6 minus 66, which gives me, let's see, -73. So the determinant of this matrix that I've created here using the vertices of the first triangle is -73. Now that I know that, the area is equal to 1/2 the absolute value of the determinant of that matrix. So I have 1/2 times the absolute value of -73, which is 1/2. The absolute value of -73 is 73. And half of 73, I could go ahead and write that as a decimal, but I'm just going to go ahead and leave it as a fraction. That would be 73 halves, like that. I mean, I guess if you would prefer the decimal there, that would be, what, 36.5 for that. So either one, 73 halves or 36.5 for the area of that triangle. Again, so that's in square units. Again, don't forget your units of measure since we're dealing with area. That's triangle number 1. Now let's use this same process to go ahead and find the area of triangle number 2. Triangle number 2 had vertices -1, 3, 6, -6, and -3, -4. Throw in the column of 1s to go ahead and make matrix A. And now we're ready to go ahead and find the determinant of this matrix to go ahead and find the area of our triangle. So again, remember your sign matrix. We have plus, minus, plus, minus, plus, minus, and plus, minus, plus. I'm just going to go ahead and use the first row of this matrix. So I need to remember for my sign matrix, I have to change the sign of my middle entry whenever I'm setting up these smaller determinants, putting it out in front of the number with that. So let's go ahead and set this up now. I'm going to go ahead and cover up my row and columns here. So I have the determinant of A is equal to -1 times this smaller determinant that I'm going to create by covering up row 1 and column 1. And that should leave me with numbers -6, 1, -4, and 1, like that. Now, I have the 3, which again I need to make negative from my sign matrix, so it becomes -3 times a smaller determinant, where I cover up the row and the column containing that number, and that leaves me with numbers 6, 1, -3, and 1 for my smaller 2x2 determinant. And then finally, setting up the last determinant, plus 1 from that row, cover up the row and the column, and I'm left with the numbers 6, -6, -3, and -4 for my smaller 2x2 determinant. So let's go ahead and compute each of these determinants and see what the determinant of this larger matrix is equal to. So I have -1 times the determinant of this 2x2 matrix. -6 times 1 is -6, and then minus -4. -6 minus -4 becomes -6 plus 4, which should leave me with -2. I have -3 times this 2x2 determinant. 6 times 1 is 6, and then minus -3. 6 minus -3 becomes 6 plus 3, which is 9. And then 1 times this determinant over here. I have 6 times -4, which is -24, and then minus -3 times -6 is positive 18. So I have -24 minus 18. That should leave me with -42. For that, now I need to do some multiplication and combine some like terms. -1 times -2 is positive 2. -3 times 9 is -27. And 1 times -42 is -42. 2 minus 27 is -25. And then -25 minus 42 more puts me at -67. So the determinant of this matrix is -67. Let's go ahead and use that then to find the area of the triangle. I'll go back up here where this was. And remember, area was equal to 1/2 times the absolute value of the determinant, which we just figured out to be -67. So that's 1/2 times 67, which is 67 halves. If you wanted it as a fraction, if you wanted it as a decimal, that would be 33.5 for that, for square units. Now let's go ahead and put that all together. Now that we found that determinant and used it to find the area, if you remember in the previous part of the clip, the area of triangle 1 was 36.5 square units, plus the area of triangle 2, which is 33.5 square units. 33.5 and 36.5 together should go ahead and give me, looks like 70 square units. 36 and 33 makes 69, and then 0.5 and 0.5 makes another 1 to make 70 square units. So overall, the area of this entire polygon that we were looking at appears to be 70 square units, as long as I didn't make some sort of a computational mistake along the way. Looks like 70 square units.